Hello friends, today we are guiding you to prepare interview questions on machine learning. In comments you can share the topic of your interest. Our team will prepare the video for you. Before continue to our session, we request you to join our channel for all the latest updates. Our team of technical and subject matter experts are working hard to create valuable content just for you. So please make sure to hit the subscribe button, like and comment on our videos, and click the bell icon to stay updated with our latest videos. What is deep learning, and how does it differ from machine learning? Deep learning is a subset of machine learning that focuses on using artificial neural networks with many layers, hence deep, to model complex patterns and representations in large datasets. Deep learning models automatically learn features from raw data, such as images, text, or audio, without the need for manual feature engineering. The key difference between deep learning and traditional machine learning lies in the complexity of the models and the amount of data required. Model complexity, data requirements, computation. Model complexity. In machine learning, algorithms like decision trees, linear regression, or support vector machines typically rely on human-crafted features. The model learns patterns based on these features. In contrast, deep learning models, such as convolutional neural networks, CNNs, or recurrent neural networks, RNNs, have multiple layers that automatically extract hierarchical features from raw data. Data requirements. Deep learning thrives on large amounts of data. While traditional machine learning can perform well with smaller datasets, deep learning often requires massive datasets to achieve optimal performance. Computation. Deep learning models are computationally more intensive, requiring specialized hardware like GPUs for training, while traditional machine learning models are less resource demanding. In summary, deep learning excels in handling complex, high-dimensional data, whereas traditional machine learning is typically more suitable for simpler, smaller datasets. What are artificial neural networks, ANNs? Artificial neural networks, ANNs, are computational models inspired by the human brain's structure and function. They consist of layers of interconnected nodes, neurons, that process and learn patterns from input data. ANNs are a foundational concept in deep learning, used to solve a variety of tasks, including classification, regression, image recognition, and natural language processing. An ANN is composed of three main layers. Input layer. This layer receives the raw input data and passes it to the next layer for processing. Hidden layers. These are intermediate layers where the actual learning occurs. Neurons in hidden layers apply weighted sums of inputs and use activation functions, like ReLU, sigmoid, or tanh, to introduce non-linearity, enabling the network to learn complex patterns. Output layer. This layer produces the final output, such as a class label or a predicted value, depending on the task. ANNs are trained using a process called backpropagation, where the error in the output is propagated backward through the network, adjusting the weights to minimize the error using optimization algorithms like gradient descent. ANNs excel at tasks involving high-dimensional data, particularly where traditional machine learning models struggle, by automatically extracting features and learning complex relationships from large datasets. What is the difference between a perceptron and a multilayer perceptron, MLP? A perceptron and a multilayer perceptron, MLP, are both types of artificial neural networks, but they differ in structure and complexity. Perceptron. The perceptron is a single-layer neural network consisting of a single layer of neurons, also called the input and output layer. It was introduced by Frank Rosenblatt in 1958 and is the simplest form of a neural network. It works by taking inputs, applying a weighted sum, and passing the result through an activation function, usually a step function. The output is binary, typically used for binary classification tasks. A perceptron is limited in its ability to solve nonlinear problems, as it can only learn linear decision boundaries. Multilayer perceptron, MLP. MLP is a deep neural network that consists of multiple layers, an input layer, one or more hidden layers, and an output layer. Each layer contains multiple neurons. The key difference is that MLP can model complex, nonlinear relationships due to its multiple hidden layers, making it much more powerful than a single-layer perceptron. MLP uses activation functions like ReLU, sigmoid, or tanh and is trained using backpropagation. MLP can solve more complex problems such as image recognition, regression, and classification with higher accuracy. In summary, while a perceptron is a single-layer, linear model, an MLP can handle complex, nonlinear data due to its multi-layer architecture. What is backpropagation, and how does it work? Backpropagation is a key algorithm used to train artificial neural networks by minimizing the error between the predicted and actual output. It is an essential part of the learning process in deep learning models, especially multi-layer perceptrons, MLPs. Backpropagation works in two main phases, forward pass and backward pass. Forward pass: during the forward pass, the input data is passed through the network layer by layer. Each layer performs computations, weighted sums of inputs and activation functions, producing an output. This output is compared with the actual target to calculate the error, or loss. Backward pass: in the backward pass, backpropagation calculates the gradient of the error with respect to each weight in the network. This is done using the chain rule of calculus, which allows the network to propagate the error backward from the output layer to the input layer. The gradients indicate how much each weight contributed to the error. The weights are then adjusted using an optimization algorithm, typically gradient descent, to reduce the error and improve predictions. The adjustment process is repeated iteratively for each training example. Through backpropagation, the model learns to adjust its weights and biases, gradually improving its accuracy over multiple iterations, epochs. What is the role of activation functions in neural networks? Activation functions play a crucial role in neural networks by introducing nonlinearity, enabling the model to learn complex patterns in data. Without activation functions, a neural network would simply be a linear regression model, regardless of the number of layers. This is because a sequence of linear operations results in a linear output, which limits the network's ability to solve more complex tasks. The key roles of activation functions are introducing nonlinearity. Activation functions allow the neural network to learn nonlinear relationships between inputs and outputs. This capability is essential for solving complex problems like image recognition or natural language processing. Determining output range: different activation functions have different output ranges. For example, the sigmoid function outputs values between 0 and 1, which is useful for probability-based tasks, while the tanh function outputs values between -1 and 1, providing a wider range. The ReLU function outputs values between 0 and infinity, offering sparse activation and faster convergence. Enabling gradient-based learning: activation functions enable the network to use gradient-based optimization techniques like backpropagation. They provide gradients that are used to adjust weights during training, helping the model improve accuracy. In summary, activation functions allow neural networks to model complex, nonlinear relationships and make them effective for a wide range of tasks. Thanks for watching the video till the end. If you liked the video and haven't subscribed yet, please hit subscribe button, like and comment on our videos, and click the bell icon to stay updated with our latest videos. In comments you can share the topic of your interest. Our team will prepare the video for you.